Thank you, Pat. And I want to, like my fellow speakers, thank the IAFF for elevating such an important topic as cancer to such a broad perspective. It's a privilege to be here and to address this group, so thank you. I want to start with a couple of questions and a show of hands. First of all, how many architects are there in the room? Get the hands up high. I don't see any. Okay, let's do something different then. I'm not surprised. How many of you have either been diagnosed with cancer or know someone in your department that has been diagnosed with cancer? Let's see a show of hands on that. This is an important topic. Last question. How many architects in the room, with a show of hands, have been diagnosed with cancer? Well, there's one of us. What that does is it takes something that I was already passionate about from having worked with this community for more than 30 years and elevated it to a level where I feel I must make a difference in changing the statistics. When I first became aware of these kinds of statistics on the health and the well-being of the crew of the fire and rescue industry, when I saw the kinds of statistics for the elevated incidence of cancer about 2012, I realized that something needed to be done. As architects, we're problem solvers. And as I looked at these stats, I made a commitment to try to do something in station design that can change these numbers for the well-being of the folks that are here today and for future generations. So what I had to do first was a little bit of research. And a number of the topics have already been discussed today. I won't go into depth, but just as a broad view, maybe from a different perspective, I came to understand that any incident that involved smoke involved exposure to carcinogens and toxic chemicals. Every single incident that involved smoke involved exposure to carcinogens and toxic chemicals. These toxic chemicals bond to microscopic soot particles that are in the environment. Now, of course, because they're microscopic, they're not visible to the unaided eye. And as a result, we're finding that we can be in environments that we think are safe but are actually hazardous. These particles have an extremely long hang time and airborne residency. So well after we think that we're outside an incident, we're still in a toxic environment. And what that creates is a high-risk environment. And being aware of that, understanding it, educating ourselves, and taking steps to control that, our challenge, designers and all of the leaders that are represented in the room today, is to isolate, capture, and to remove the carcinogens from our living and working environments. So let's think about how we get exposed. There's an incident. We go tearing out to the incident, of course. We deploy all the resources available, manpower, equipment, tools. In the process, everything that's used, everything is exposed to contaminants. And unless there's careful cleaning at the site, those contaminants are loaded back into the apparatus, on our clothing, on our bodies, and brought back to the station. Unless we control the contaminants at the station itself, that leads then to cross-contamination and spreading of those contaminants within the facility. Well, of course, we get another call. It's like the shampoo cycle, rinse and repeat. I used to say that a single incident wouldn't kill you. Commissioner Finn is going to talk about a power plant incident where probably a single incident can be tied to a number of deaths. FDNY knows the impact of 9/11 and the residual impact for those that were responding afterwards to clean up after the incident. But we do know for the pedestrian, regular, everyday incident, repeated exposure and cycles essentially creates a carcinogen harvesting system. We go out, we encounter them, we bring them back, we deposit them at the station, and then we live and we work there for 24 and 48-hour shifts. So we've already talked with some of the other speakers about absorption, ingestion, and respiration as pathways for those contaminants to get into the system. I'm going to touch on that just very briefly. But one of the facts that I had heard is every 5-degree rise in skin temperature, 400% increase in absorption rate. We know firefighting is a strenuous, hot exercise. You're exposing yourself, so as we talked about the thinness of the skin, also allowing for contamination. The fact that we're elevated with our temperature is like a wick. It accelerates the contaminants. We've just seen this study. IAFF is to be commended for bringing this forward and understanding how contaminants can get through our defensive systems and get to the skin itself, where it can get absorbed into the system. And as we think about other ways, ingestion, how can the food or the drink that's consumed on site, or the food and the drink that's consumed back at the station, if we haven't decontaminated it, allows for those contaminants to enter your system through ingestion. Vending machines, ice machines that are located in the apparatus bay are probably pretty common. Yet that food and that drink is then potentially subject to exposure because of the vehicles that have returned, been cleaned in the bays, and those contaminants gotten into the food or the ice. Very quickly on respiration. What you see is the size of the particulate and how it is so small at less than 2.5 microns, it can get to the innermost lining of the lungs, where the air exchange occurs at the cellular level between the bloodstream and the lungs. Particulates can get down to that level. And oh, by the way, the surface area of the lungs, 80 times the area of the skin of the human body. So we're talking about a lot of surface area. So SCBA during overhaul and rehabbing on the scene is important. We need to recognize the hostile environments that exist at the scene or those that are created back at the station. Diesel exhaust control is a critical issue that we need to recognize and manage at all of our stations. There are at least 4 methods for controlling diesel exhaust. I've listed them here and I won't go through the details of it, but if we're not doing something to control and regulate the diesel exhaust at the station, we're allowing a hostile environment to be created where we live and work, and that's part of the root problem. What it comes down to is education and a fundamental change of culture. You've heard that probably earlier today. You're going to hear that again later on. It's not an easy thing to do, but we've got to move the bar. The stakes are too high. New Jersey, and what you see here is the way that a station that's well designed, laid out, is organized around efficiency, function, quick, rapid response to the apparatus bay, safe delivery of services to the community. This is what you should expect from every single architect that you work with. However, we tried to apply a different lens to the design of the station with this first building, and we took the hazmat design that we just talked about for the incident and transferred that to lay that over station design. So we've tried to create hot zones, the red zones, those areas that are most subject to contaminants. We separated them from cold or safe zones, labeled them green, and then focused on the transition or the warm zones, the yellow zones in between those two, and developed a design strategy that's structured around containing the contaminants at the station and separating the occupants from those zones. And what you'll see now is that that color code looks a lot different here. All of the red zones are grouped together, all of the green zones are separated, and at this first station, we had 3 decontamination corridors that we focused on as the way to move back and forth between those zones. So let's think a little bit about some of the strategies that might be utilized in implementing this type of design. We're suggesting that we should focus on containing the contaminants, that we separate the occupants from the contaminants, that we control or limit the crossover and we pay attention to those transitions, and that at the very end we think about enhanced decontamination at the station itself. So one of the things that's critical, thinking about each of these zones, is self-sufficiency. And you'll see that that shows up in each one of these slides. So when we talk about the hot zone, those spaces that are potentially exposed to contaminants, anything that goes out on a call comes back and is grouped together here. It's apparatus bays and all the equipment support. So now a close-up of that bay support area in the center, you'll see has SCBA, it has PPE storage, it has the workshop, it has a separate decon area with a commercial laundry, an extractor, hose storage, training mezzanine, all grouped together in what we're proposing as the hot zone. And then, likewise, creating a safe living area elsewhere. This cold zone space are all of the spaces intended for human occupancy of any kind, the sleeping spaces, the day spaces, the office spaces, the PT workout spaces, not in the bay, but in the clean, safe zone. And then thinking now about how we cross over between these zones. Again, think about self-sufficiency. So honing in on those support spaces in the middle, you'll see that we've provided a toilet that's out in the hot zone area. Inevitably, nature's going to call when you're working out there. The intent is to not go into the clean zone to have to respond to the call, to be able to stay out in the work zone area. Separate decon, separate laundry for the small rags or linens and types of cloths that are associated with the bay, stay in the bay. A separate janitor's closet and a separate cleaning supply area. Things should stay in the area in which they're used so that we don't spread contaminants back and forth between the zones. And of course, separate mechanical systems goes almost without saying. So let's look at where the greatest growth in our concepts have occurred. That's around this idea of the transitions. This is essentially 1.0 with this first design that we've developed. We're trying to think decon now throughout all of this. So the first thing is, let's be real clear. No gear goes into the clean zones, ever again. Put a sign up. It's really easy to do if you haven't implemented it already, but don't allow the contaminants from the gear to be tracked into the living quarters. And here's maybe the culture change. Call out your crewmate that's violating the rules. It's for his health, his well-being, his family, his kids, and it's for yours. Accountability. You know, they've got your back on a call. You should have their back here at the station. When I'm not an architect, one of the hats that I wear is Board of Trustees at Sibley Memorial Hospital in Washington, D.C. And we have found, we understand, the single best way to control the spread of disease and infection at a hospital is to wash your hands before and after every encounter with a patient. Whether it's a nurse, whether it's a doctor, whether it's an administrator, that's the highest single most effective way to control it. Why not apply some of that thinking to a fire station? So we've proposed sinks or hand sanitizers at the entrances into the living quarters as a way to keep your hands clean as the most effective way to limit the spread of contaminants. We've also suggested that we could have walk-off mats in this corridor area as a way to keep at least some of the stuff from tracking into our living quarters. This represents our most recent thinking. It's developed over the course of a couple of years, and you'll see that those 3 corridors have now expanded into an entire zone. So let's think about this. This is a design for King George Fire Station, currently in design in Virginia. And we'll do a blow-up of that central zone area. Recognize that not every call is going to generate exposure to contaminants. So for those calls when you're returning, we want to provide a bypass that allows you to go straight into the living quarters without going through enhanced decontamination. You'll see those 2 corridors at the top and the bottom. And along those 2 corridors, what we install are hand sinks and boot washes to encourage cleaning of your hands and your boots on a regular basis. We also create an airlock so that it's not just a single door between the spaces, but it's a separate zone that prevents the air being transferred from the apparatus bay into the living quarters with this separate zone. Located the ice maker in the zone where it's readily accessible to the apparatus bay, but it's not in the same environment as the diesel exhaust is being released. So what happens though when you are exposed? When you do have a fire, dumpster fire, auto fire, structure fire, electrical fire, whatever it might be. So when you come back from that call, rather than bypassing, clean up your apparatus, probably do this in shifts, but you enter into this central hub, this decon area. It's outfitted with a stainless steel 3-compartment sink for cleaning off the breathing mask and the helmet. There's a trench drain. There's a large gross decontamination shower if that hasn't already occurred, an eye wash. The idea is that that's where you arrive. And then the equipment moves in one direction. So the gear laundry is immediately adjacent to this decon hub. And then adjacent to that is the PPE storage area. Allows you to clean your gear, put it back in the locker, and both of these spaces are immediately adjacent to the apparatus bay for ready access to the bay. However, personnel go in the other direction. After your gear has been disposed of and is cleaned up or positioned for the next call, we want to try to clean the contaminants that we saw got through the gear and onto your skin. So we're proposing pass-through lockers. These show full-height lockers that are double-sided. They might be cubbies, but the idea would be when you come on shift, you put your second uniform in there, or you put in a set of gym clothes so that when you come back from a call, you can pick it up on the other side. You then proceed into this toilet with a shower. You take a shower within an hour. Most effective way to get the contaminants off your skin. You've got your dirty uniform with you. As you exit, you go through the uniform laundry, drop your uniform in the laundry, and you're back in service. So all that being said, that's new design thinking. Not everybody's working on new designs, yet everybody's got an inventory of existing structures that probably don't have any of this kind of thinking in place. What we're finding now is that departments are calling us to come in, do some studies on the existing buildings, to do a survey and to start to talk about renovation triage. We can't wait for the industry to catch up with all new building designs, plus we've got the inventory of existing structures that need to be addressed. So the kinds of things that we're looking at when we do this is PPE handling. Is it in an enclosed room? Is it dedicated mechanical with direct exhaust, or is it hanging in on the wall in the bay as it has traditionally done for generations? When that happens, diesel exhaust can get embedded right into the gear. The gear is then put on, and any of those particulates are put in direct contact with your skin. When you get hot and sweaty and start to absorb again, it becomes a highway for contamination. So getting the gear out of the bays is critically important. We look at decon. We look at the adjacencies of equipment. Is it a good idea to have an ice machine right next to a cleaning sink? Probably not. We look at hands again, and signage, and hose drying. Any equipment that's gone out in service has gotten exposed to contaminants. If it isn't clean, it's still contaminated, potentially conveying that to the next shift or off-gassing into the space. Exhaust removal systems. We look at what else is in the bay. Often becomes a catch-all for a variety of storage spaces. Our vending machines and ice machines located in the apparatus bay, as you see in this photograph. Well, thinking about that, that's exposed to contaminants here at the station. We're then taking that food or that drink, we're consuming it, we're ingesting it, we're transferring those contaminants into our system. Workstations. PT is probably, if I was to ask here for a show of hands, who knows of a workout system that's somewhere in an existing apparatus bay? I'd probably get every single hand up in the room. That's an accelerated physical environment that allows the contaminants to get into your system through both respiration, ingestion, and absorption. And finally, supplies. Things should be stored in the safe space or in the red zone space and not cross-pollinated. There's a lot of thinking, There's a lot of information. We're just pushing the boundaries, and because construction takes a long time to occur, the industry is lagging, but we're at the forefront of some really important changes in the design, probably the most important trend in all of architecture right now for fire and rescue stations. I'm going to be hanging out over by the Firefighter Cancer Support Network afterwards. If you want to talk further, I'd love to talk with you about this. It's important. Thank you very much.